Hey guys, it's Tiffany. Today I'm going to show you how to solve equations in two variables. Solving equations with two variables using the substitution method. The steps you want to follow when solving an equation with two variables is first you want to isolate a variable. It doesn't matter which one, you can choose whichever variable you want. After that, you want to substitute the value of the isolated variable into the other equation and calculate the value of the other variable. Finally, the calculated value can be used to calculate the value of the first variable. Let's take a look at example number one. Example number one. If I have the two equations x plus y equals 5 and 2x plus 3y equals 13, the first step that I'm going to take is to isolate one of these variables. Right now, these two problems have 4 total variables. There's an x here, a y here, an x here, and a y here. I'm going to look for something that's already by itself. It could already be isolated, or I'm going to look for something that is pretty close to isolated. So first of all, I'm noticing that my first equation has 2 variables and they both do not have a coefficient. So I'm going to work with this one. X plus y equals 5. If I isolate the y, that means I'm going to get the x over on the right, and I'm left with y here, and that equals negative x plus 5. I could have also put my minus x after the 5, and that would have looked like y equals 5 minus x. Both of these are the exact same value, okay? So this one is the exact same as this one. Either one is correct. Now, if you remember, my direction said after you isolate one variable, you're going to plug in the value that you got for that variable into the other equation. So we just worked with the first equation. Let's look at the second equation right now. And let's rewrite it. So I have 2x plus 3y equals 13. Now I'm going to plug in the value that I just got for y, which is written right here, into this equation, okay? The second one. I'm going to write the equation again, but when I get to the letter y, I'm not going to write a y in. I'm going to write what I calculated y to equal. So it's going to look like this, 2x plus 3, and instead of y, I'm going to write 5 minus x equals 13, okay? Now I'm going to solve for the x. I only have one variable in this problem now, so now I can isolate my x. And that means x is going to be equal to an actual number this time, okay? It's not going to be equal to some number with a variable over there. So it's going to be like a clear answer for what x actually is, okay? So I can see that I can do the distributive property right here. So that means 3 times 5, and 3 times is negative x, okay? That's going to look like 2x plus 15 minus 3x equals 13, okay? Now I'm going to combine everything that I can combine, all right? I have 2x and I have a minus 3x. Those can combine. They're both x values, okay? So I'm going to start with 2 and take away 3, and that leaves me with negative 1. But I don't have to write the negative 1. I could just write negative x, okay? Then I'm left with the plus 15, and that equals 13, okay? Now I can move the 15 to the right, and I'm left with negative x equals negative 2. Now, when you see something like this, where you have one term on either side of the equal sign and they're both negative, just a quick thing to note, you can just basically drop the negative signs. What you're really doing is, if you say it's negative x equals negative 2, this is like a negative 1, so you're really dividing by negative 1, but it's I'm just skipping that step because this would leave you with x equals a positive 2. Now, we're not done. All I did was plug in the value that I got for y, remember over here, into the other equation. So the only thing that I actually officially have now is my x value, okay? X equals 2. Now I need to plug in x equals 2 to the other equation. So I'm going to take my x plus y equals 5. So it's 2 plus y equals 5. Subtract 2 from both sides because I'm isolating y to figure out what it's going to equal. This goes away. I'm left with y equals 3. So the answer to this problem is x equals 2 and y equals 3, okay? That could be written as an ordered pair. It could be written as 2, 3, okay? What this is saying is if I were to plug these two numbers into these two equations, I would get correct answers, okay? Let me show you that. Okay, so I erased everything so I could have a little more space to work. But if you remember, it was 2, 3 that I got. So I had an x value of 2 and I have a y value of 3. So what I'm going to do is I'm going to show you that when I plug in these two numbers to both of these equations, I get true statements. I get correct statements, okay? So I'm going to start with my first one, x plus y equals 5. And instead of writing x right now, I'm going to write what x equals, 2. 2 plus, instead of writing y right now, I'm going to write what y equals, 3. Okay? And that equals 5. Is this a true statement? Is does 2 plus 3 equal 5? Yes, it does. 5 equals 5. Okay. Now let's do the same thing with the second. 2x plus 3y equals 13. Plug in the exact same numbers. Instead of writing x again, I'm going to write the 2. 2 times 2 plus 3 times 3. Does that equal 13? Well, 2 times 2 is 4. Plus 3 times 3 is 9. And that does equal 13 because 4 plus 9 is 13. So that is true. So what does that mean? It means if you would have gotten anything else besides x equaling 2 and y equaling 3, and when it was time to like plug it in at the end to check, you would have equations down here that did not equal, okay? So let me show you what I mean. Let's say you calculated the wrong answer because you did your math wrong somewhere, okay? And let's say you got 2 for x and you got 4 for y. When you go to plug in, you're gonna end up with something that's not correct. So you have x plus y equals 5, right? And your x is 2 plus y, which is 4, and that equals 5. 2 plus 4 is 6, and that equals 5. Is that true? No. That means you did something wrong. You could also slash the equal sign. Okay? Let me show you over here too. 2x plus 3y equals 13. Instead of writing x, I'm going to write 2. Instead of writing y, I'm going to write 4. And that equals 13. 2 times 2 is 4. 3 times 4 is 12. Equals 13. 4 plus 12 is 16. That is not equal. So something's wrong. Okay, you did something wrong. When you get the correct answer, when you plug it back into both of the problems, it will turn out to be true statements, just like these, okay? It'll turn out true. It'll be something equals something. If you plug it in, you get the wrong thing equaling something, you did something wrong. Let's take a look at example number 2. All right, example number 2. Again, we're gonna start by isolating a variable. Now, when I look at this, I can see that none of my variables are really by themselves as much as like my last example, okay? So I know that I'm gonna do a little bit more work to isolate the variable, but that's fine, I can do it. Okay, I'm gonna say, how about I isolate this 2x? And I'm just choosing it because 2 is a little bit smaller number. But there's no right or wrong. Just pick anything. All right. So let's say 2x plus 5y equals 26. Now I'm going to move the 5y to the other side. And I'm left with 2x equals 26 minus 5y. And now I'm going to divide both sides by 2. And I'm left with x over here equals 26 divided by 2 would be 13 minus 5 over 2y. Okay? Now, this is a little more complicated. I actually kind of feel like maybe I didn't want to isolate this because I don't want to deal with a fraction, okay? That's kind of annoying. Like, I'm probably going to have to distribute. Like, I actually kind of don't like it. So let me actually switch right now. And this is great for you to see because sometimes I'm doing a problem and I'm like, do I really want to go that route? No. That's like going to give me more work. So actually, let me isolate something from this top one. Okay, it might work out to be something that gives me a little less work. Okay, so I'm going to erase everything on my screen to give myself a little more space. Let's start again. See if I get some better numbers. 6x plus 3y equals 30. Okay, how about I'm just guessing, let's isolate the y right here. Okay, so move 6x, let's move that. Okay, I'm left with 3y equals 30 minus 6x divided by 3 divided by 3. Y equals 30 divided by 3 would be 10. And 6 divided by 3 would be 2x. Now, since I isolated this y, okay, on the top equation, I'm going to plug the value that I got y to equal this 10 minus 2x into the second equation, okay? So I have 2x plus 5y equals 26. Now I'm going to rewrite this, but instead of writing y, I'm going to write what I calculated y to equal down here. So it's 2x plus 5. Instead of y, I'm going to write parentheses 10 minus 2x equals 26. Now I'm going to solve for x to get an x value. Looks like I can use the distributive property right here. So I'm just going to draw some arrows so you know what I'm doing. So this is 2x plus 50 minus 10x equals 26. All right. Now I'm going to combine like terms. I have a 2x. I need to take away 10x. That would leave me with negative 8x plus 50 equals 26. Now I'm going to put this 50 over here. I'm left with negative 8x equals negative 24. Okay. Now I'm going to divide by negative 8 on both sides. And I'm left with x equals 3. All right. So now I have an x value. Now I need to calculate a y value. So I'm going to take this x equals 3 and I'm going to plug it into the first equation that's on top, the one that starts with the 6x. Okay, so I have 6x plus 3y and that equals 30. Okay, now I'm going to rewrite it except for when I get to x, I'm going to write a 3. 6, 3 plus 3y equals 30. 18 plus 3y equals 30. Subtract this 18. Now I have 3y equals 12. Divided by 3, y equals 4. Okay, so now I have 2 points. I have x equals 3, and y equals 4. And you could write that as 3, 4. Okay. Now I'm going to clear everything off of my screen and I'm going to write the point 3, 4 up at the top of the screen. And I'm going to show you that plugging in these 2 points gives you the correct solution. All right. So my x value is 3 and my y value is 4. So let's start with the 6x plus 3y equals 30 equation. 6. Instead of writing x, I'm going to write 3. Instead of writing y, I'm going to write 4 and 30. 6 times 3 is 18 plus 3 times 4 is 12 equals 30. That's right. 30 equals 30. Right? Okay, that's good so far. Now I'm going to do the same thing, but with the other equation. 2x plus 5y equals 26. 2, what's x? 3. 5, what's y? 4 equals 26. 2 times 3 is 6, plus 5 times 4 is 20, and that does equal 26. So as you can see, both of these worked out correctly. If I would have plugged something in and it ended up not equaling at the end, I didn't end up with a something equals something, and it's the exact same thing, and something equals something, then I know I did something wrong, okay? Now, let's try a word problem. Example number 3. 5 shirts and 3 blazers cost $165. From the same shop, 4 blazers and 6 shirts cost $212. Find the selling price of blazers and shirts. All right. First, you might be thinking, how do I go from this word problem, this scenario, to an equation? So this says 5 shirts. I'm going to cross out the word 5 and I'm going to write the number 5 because I want to see the number in my problem. Okay. 5 shirts and 3 blazers cost $165. So that is your first equation right there. Without you even doing anything, they're plain old telling you an equation, okay? I'm going to write this as 5s for 5 shirts. And what operation does that make you think do? It makes you think add. 5 shirts and 3 blazers, so 3b, cost $165. Cost is basically your equal sign. 165, okay? That's not too bad, right? Hopefully. It tells you what this is when you look at it. 5 shirts plus 3 blazers equals $165. Okay, that's not too bad. Yeah, okay. It's like makes sense when I'm doing it, right? Okay. From the same shop, 4 blazers and 6 shirts cost $212. Okay, think about how is that gonna be? What are we gonna do? Okay, 4 blazers. Let's consider the model I did over here. So let's write that one as 4B. Okay, and 6 shirts. What did I do the first time? I basically did the same thing, a number and a letter. So and means plus. 6 shirts cost $212 equals $212. See, that really wasn't that bad. I mean, these sentences straight up tell you what it is, okay? When you first see it, you might not, you maybe can't pull it out. You're like, what? I'm not sure what to do. It's really not that bad. Now, here's one thing I'm going to say, do. Once you get your equations written down, you need to change your letters. I like to write the letters in reference to the actual scenario from the word problem. But later you want to say, hey, S is my X and B, those are going to be my Y's. Okay. So now I'm going to rewrite both of these. And instead of S's, I'm going to write X's. And instead of B's, I'm going to write Y's. So 5x plus 3y equals 165. And then 4y plus 6x equals 212. Look at that. We took a real life scenario and we made 2 equations out of it. Okay? Now I'm going to take these 2 equations and I'm going to solve them just like I did on the last 2 examples, okay? So how about I isolate this y? So I'm going to say 4y plus 6x equals 212. Move this over. 4y equals 212 minus 6x. Divide by 4, divide by 4. Y equals 212. What is that? What's in here? 5 times remainder 1, 3, minus, let's see, 3 over 2. I guess that's not terrible. Now I'm going to plug this value into the other equation. 5x plus 3y equals 165. Okay, I'm at the y. Instead of writing y, I'm going to write what I calculated y to equal, which is 53 minus 3 over 2x, and that equals 165. Okay, now I'm going to do distributive property. 5x plus what's 3 times 53? Let's see, that would be 159 minus 9 halves x, which equals 165. Okay, this is getting a little complicated. I have a 9 over 2, and I have a whole number of 5 for my x's, okay? So I need to make like common denominators, so I could just say, hey, this whole number of a 5, this 5x is the same thing as 5 over 1, and then I'm gonna basically double it. I'm like unsimplifying, okay, so that I have common denominators, okay? So instead of 5 over 1, this is 10 over 2, which is the same value as 5. Okay, I'm just putting in a format that is useful for me now. So now I have basically the problem 10 over 2 minus 9 over 2, because I'm trying to combine this part with this part, okay? And I'm left with 1 over 2, okay? So I have 1 over 2x plus 159, which equals 165. So now I'm subtracting my 159 from both sides. And this is getting a little messy. Let me put this in a box to make sure you understand that this is the start of this equation, okay? And I'm left with 1/2 x equals, what is this, 6. Now, this is saying you have 1/2 times x. So to undo that, you would divide. If I were to do this in my head, honestly, I would say 1/2 times what is going to give me 6. So basically, I know that this 1/2 is going to half some number to give it 6. So basically, the opposite of that would be doubling the 6. Okay, so I know my x right here is going to be 12. So x equals 12. If you didn't understand that, you could follow the rules of inverse operations. The 1/2 is being multiplied by the x. So the opposite of multiplication is division. So you would have to then divide the 1/2 on both sides. And remember, when you're dividing a fraction, you're going to keep it, change it, flip it. Okay, that means you're going to be multiplying by the reciprocal. And so the reciprocal of 1/2 is 2. And so that would be multiplying both sides by 2. So the 6 would become a 12. Now I'm going to take this x equals 12 and plug it into the other equation, the one that I'm not working with, which is the 4y plus 6x equals 212. Okay, now I'm going to rewrite it, except here it's time for me to write x. Instead of writing x, I'm going to write 12. 4y plus what's 6 times 12? 72 equals 212. Okay, subtract 72, subtract 72. 4y equals 140. Divide by 4, divide by 4. Y equals 35. So my answer here, x equals 12 and y equals 35. And remember, these were coded. X, that was my shirts. And Y, those were my blazers. So the question is asking, find the selling price of blazers and shirts. And I know that the shirts cost $12 and the blazers cost $35. Now let's take a look at what that means in a more real world perspective, not doing the substitution method, okay? It's saying, if I have 5 shirts and they're all $12 each, which gives me $60 worth of shirts. And I have 3 blazers and they're all $35 each, and that gives me $105 worth of stuff. The total of those two is $165, okay? And that was our first equation. We had the equation 5s plus 3b equals 165, okay? Makes sense. 5 shirts sold at $12 each plus 3 blazers sold at $35 each equals $165, okay? This is a sensible real world scenario, okay? This makes sense. Now, from the same shop, you could have bought 4 blazers and 6 shirts, and that would have cost $212. And that makes sense now that you know that 4 blazers means you're gonna pay $35 4 times plus 6 shirts, which means you're gonna pay $12 6 times, would give you $212, okay? The 4 times 35 that you're paying for the blazers totals $140, and the 6 times 12 that you're paying for the shirts totals $72, and that's where you get your $212 from, okay? This is a very real world scenario. It's like, this is like real. You could really do this. It's not just some kind of like out of touch example or something, okay? Let's look at example number 4. Example number 4. Sarah spent $168 on plates and bowls for her restaurant. The price of a plate is $5, while the price of a bowl is $4. If she bought 12 more plates than bowls, how many plates and bowls did she buy? Okay, let's see what we can take out of here. Here's a tip I want to point this out too. Usually, not always, your dollar amounts will all go together. They're all going to be in the same problem. It's not always perfectly that way. It just depends on what your problem is asking or explaining, but a lot of times it will be. You'll have one problem that's just dealing with like how much you're spending, your prices on stuff, your totals you spent or something. It's all dollar amounts. Then the other problem is more like dealing with like the quantity, okay? So let's look at it right here. The price of a plate is $5, while the price of a bowl is $4. So I'm gonna say 5p, because for every plate that you buy, you have to spend $5, okay? Plus 4b, because for every bowl that you buy, you have to pay $4, okay? Well, that equals $168, okay? So this is my money equation, okay? Now my other equation talks about like the ratio of plates to bowls. It says if she bought 12 more plates than bowls, how many plates and bowls did she buy? That would look like Well, your bowls plus 12 is going to equal your P, okay? It tells you she bought 12 more plates than bowls. So your bowl amount is going to be less, but if you add 12 to it, it's going to equal your plate amount, okay? Now I'm going to follow the exact same steps that I've done all along, okay? I'm going to find something to isolate. Oh, guess what? They helped me out here. For this particular example, I don't have to find something to isolate. I already have an isolated P. I'm going to use that because it's going to keep me from having to do that step. I'm going to just go ahead and let this second equation work for the variable that's already isolated. Now I'm going to plug in what P equals into the other equation. So instead of writing P down, I'm going to write B plus 12. So it's 5 times B plus 12 plus 4B equals 168. Now I'm going to do the distributive property. 5B plus 60 plus 4B equals 168. Okay. Now I'm going to combine like terms. I have a 5B and a 4B that equals 9B plus 60 equals 168. Subtract 60 from both sides. 9B equals 108. Divide by 9, divide by 9. B equals 12. Okay, now I'm going to take that value for B and I'm going to plug it in to this equation. So 12 plus 12 equals P. 24 equals P. So the value for P is 24. Okay, so what this means is bowls or B equals 12 and P or plates equals 24. Okay, and the question asks how many plates and bowls did she buy, and I'm pointing that out to make sure you don't think that these are dollar amounts. These are quantities. The 12 tells you how many bowls. The 24 tells you how many plates, okay? And of course, if I were to do the same thing that I've done all along, and I plug in these values to my original equations, I'm gonna get true statements. Let me show you that. Okay, so my original equation that I wrote was 5P plus 4B equals 168, and it was B plus 12 equals P. And if you remember, B equals 12 and P equals 24. Okay, so 5P will be 24 plus 4B, which is 12, equals 168. 5 times 24 is 120. 4 times 12 is 48. And that equals 168. 120 plus 48 equals 168. So 168 does in fact equal 168. Same thing over here. Plug everything in and see if it is correct. B, we know is 12 plus 12, and P, we know is 24. 12 plus 12 is 24. So yes, 24 does in fact equal 24. If you plug everything in and you get something that does not equal itself, then you did something wrong, and that's your cue to say, let me try to solve this again. Now, let's take a recap. When solving an equation in two variables, the first thing you want to do is isolate a variable. Remember, you can choose whichever variable you want, but some variables may be positioned in the equation in a way that makes the math a little more difficult. So if you get to a place where you're solving for a variable and you notice you end up with some difficult numbers to calculate, like a lot of fractions or something, it's okay to say, you know what, I think I'm going to isolate a different variable that's going to work out a little easier for me. Totally understandable. After that, you're going to substitute the value of the isolated variable into the other equation and calculate the value of the other variable. Finally, the calculated value can be used to calculate the value of the first variable. Now you try. Comment with the two numbers below. The sum of two numbers is 25. Their difference is 3. What are the two numbers? After you've solved this problem, head over to my website, supereasymath.com, click on video answers, and see if you got your answer correct. supereasymath.com. Don't forget to like and subscribe. Did you find this video helpful? Well, you can get more help from me on my website, supereasymath.com. While you're there, you can pick up my top 5 math tips to make learning math easy.